If you haven't guessed, today we've got a Microsoft MVP, Kathleen Dollard. I'm pronouncing this right and I didn't butcher it. She's been an MVP now for Microsoft for 14 years. Now, one thing you might want to know, and that she wanted to point out, is that Microsoft MVPs don't work for Microsoft. There are people who know Microsoft technology, and she can tell you about it. But in any case, she's one that really knows Microsoft technologies. Now, one thing I'm upset with, remember me and iPads? She has an iPad. Darn. Okay.
Are there any other tablets?
Pardon?
Are there any other tablets?
There are going to be a lot of them, potentially. In any case, what I'd like to say is I'd like to thank Cap Strategies today for the facilities, and there will be a couple of other sponsors who will do some things that we're going to raffle off at the end of today, and Matt's going to take care of that, and possibly Jose, are you going to do it? Okay. But in any case, glad to have Kathleen here. She is transiting between Ann Arbor from yesterday, where she talked, and she's going to be in Colorado tomorrow. And she decided to make it and talk to us. So I'd like to have a hand for Kathleen.
Thanks, thanks. Is this too loud or are we good to go? It's a little loud. Okay, great. Okay, so first of all, I want to thank you guys so much for coming out Friday night. That's absolutely awesome. I don't know that I've ever been able to speak to a user group on Friday night, and it's because it's the only night I could be here. So thank you so much for taking your Friday night, spend a little bit of time with me. It's absolutely great. The way I start my talks is I say just one or two things about myself, which is what's on the slide. My company is Crystal Meth Lab. That's with an F. I know it's 420, but it's still with an F. So what is 420? Why is it important? That's because it's 2 days before Earth Day, right? I have no idea. Okay, never mind. I'm working on a .NET coaching practice, meaning that I try to work with teams in place to make the teams better without disrupting current projects. And so that's what the practice I'm starting up, doing a lot of speaking in the meantime. Also working on some Pluralsight videos, Visual Studio tips and tricks. So hopefully that will be out by around the 1st of June is my hope. And so when that comes out, hopefully you guys will be able to go watch it. Hopefully you'll take a look at Pluralsight. I think they're doing fantastic stuff. It's a great format. It's a fantastic format for tips and tricks. And it's likely that my course itself will just about pay for your subscription because of making you faster and more efficient for a given year. The way I'd start my talks, especially user group talks, excuse me, is I ask people to ask me questions to start with because then I know what you're interested in. So you can ask me questions about what I do, what an MVP is, what I think about some technology that you're concerned about, or kind of anything about the industry or about me or about being a programmer today or anything you want to ask. So I take 3 questions before I start, and I really do wait. So you really do have to ask questions or it'll be a slow start to the talk. So who wants to be brave and ask the first question? It's always the hero, the person who's looking around going, okay, who's going to ask the first question? Come on, not me. So who's going to ask my first question? I tell you, in Lansing last night, man, they were just like right on it. I had 3 questions, bang, bang, bang. But I can outweight you. Come on, somebody can do this. Are you going to ask me a question? You got the mic. You're just going to hand the mic around. Come on, somebody can do this.
Do you think state-based workflow is actually going to pan out?
And you mean state machine workflows? The question is, do I think state-based workflow, state machine workflow is actually going to? So I have to preface this with the other question, which is workflow going to pan out? So how many of you guys are using Windows Workflow today? You asked the question, so I'm assuming you care to some degree. Anybody else, even somebody else, are you actually using it? 4.0 actually deployed?
In the process.
Good. You're one of 3 people on the planet. Congratulations. I think that's awesome. So workflow is a political problem right now. Microsoft is not putting any marketing into it. And the last time that was true of workflow was a bad sign. And I don't think it's a bad sign this time, but I'm going to be a lot happier when we actually hear things like SharePoint moving to it. So right now, in terms of workflow in general, I really don't know where that product is going. Microsoft has just been so bad on the marketing, and I'm sorry, you don't want to hear that. And I hope your boss isn't here, because he really doesn't want to hear it. But I really don't know. I think state machines is what we have to do in workflow. I think that the state machine, as far as I know, the state machine they've done is probably good enough. I haven't actually played with it much, so I don't have a good answer for you. OK, 2 more questions. That was a great question. Lee.
Do you do anything with Windows? Do you do anything with Windows Phone 7?
Do I do anything with
Yeah.
Windows Phone 7? No, actually I don't. So I don't. I hope to eventually do Windows Phone. I hope eventually we're going to have an operating system on a phone that lasts like more than 2 years. We haven't had that yet, have we?
No.
Yeah, we haven't. So, and we might not right now. Because there's been a couple of leaks from Microsoft. It's including Paul Thurrott, who's pretty big in the IT space, has said that the next phone is going to be a WinRT phone. It will have backwards compatibility to Silverlight, but it will be a backwards compatibility module, not a that's my major way of living kind of a module. That's not inside information for me. I'm simply saying what, and Paul's saying it, I think Mary Jo may be saying it, and then there was a little bit of a leak from a Microsoft person about some backward compatibility issues that definitely implies that that is where they're going.
Have you heard that? Not a third question.
No, somebody else has to ask you the question.
Follow
yeah.
up to that for question. Have you heard about that they may possibly not update any of the Mango phones to Apollo and just start?
Yeah. So this was
scratch?
actually the leak that happened with a Microsoft employee, and there is no announcement that they will. In fact, a semi-announcement was rescinded. So I would got no clue. The Windows Phone is a mess. It's an absolute mess, and they may be just saying we're going to throw our hands up one more time, start over one more time, and do a WinRT phone, and we're just going to fake it between here and then with whatever's convenient. And that's a terrible shame because they keep kicking the WinPhone developers. So I imagine, remember that thing with Steve Ballmer stood up and he said, developers, developers, developers? What he really said is under his breath, he was going, developers accept WinPhone developers. Developers accept WinPhone developers. So I really think they've abused their WinPhone developers pretty badly, and I hate to see it. But we're eventually going to get a Windows Phone. Eventually Microsoft will be in that space because eventually Apple will fall down enough and do enough stupid things that the space will be open, and I don't think Google will hold the space.
When is that going to start?
2 years. 2 years. I don't know, maybe now, but maybe 2 years. But I do think we'll eventually have something that's good in that space. They're just eventually going to be good. So one more question from somebody. Nobody's from this side of the room has questions. I'm going to look at you guys, because nobody over here has asked a question yet. But somebody over here can ask one. One more. Come on, guys.
What color car you drive?
Do I really have to count that? I can tell you. My car is blue. I have a blue Hyundai Veloster. And you don't even know what a Veloster is, so yeah, you can look it up. Go ahead.
I'll ask a question. I
Thank
have
you.
actually not been keeping up with all the buzz on what's happening with Windows 8 and all the noise, so I have no clue. So if I say anything stupid, I'll just apologize in advance.
You are brave enough to ask a question. Everybody else is totally happy with that.
But my question is, and part of the reason why I haven't done this is just a general sense of angst and despair and just fed up.
Angst and despair.
Well, with just
You're a .NET programmer.
Yeah, well, from what I've heard in the direction that it's going, you know, I heard the early rumors about HTML5 and JavaScript and all this stuff. So my question is really, what's the strategy? What's going on with Windows 8? What's development going to look like on that
Okay.
platform?
So I do have a slide coming up that's going to say a little bit more, but I will say, first of all, you know, it was only like 5 years ago that I had to actually try to explain to people there might be more than one platform, because web forms and WinForms are so different. It wasn't the same app. And that we might be going to different platforms, and now we can't seem to keep the same platform for a year and a half. So it's a very difficult time on that side of our world. The UI, the client side, is just changing all the time. So I'm going to show a slide about XAML and JavaScript and that world on Windows 8 once I go. So I'm just going to give you just a minimum answer right now. And that is actually that I think it's heading towards a little bit of resolution, but we're probably 3 years out. So XAML's probably here to stay. JavaScript's probably here to stay. But when you say JavaScript, you're not actually saying very much. You're just talking about, that's like saying C++, Kernighan and Ritchie. I mean, you're not really saying a whole lot. So how well are we actually going to focus in and stay on the libraries that they're looking at, like in this single page application? They're pulling libraries in. How are they going to stay on those? And what are we going to do for libraries on WinRT? There's some enormous questions still out. So I do think we're 2 or 3 years of continuing a little bit of chaos on the client side, and that's absolutely what developers do not need. But it's just as bad in open source. So it's not like we're alone in it, but it's pretty bad right now.
What does it mean for .NET?
What does it mean for .NET? It means that you better be writing server-side code and doing as little as possible on your client right now. If you're writing certain types of application, that's a non-answer. You can't do it that way. But for most applications, we're heavily being pushed towards some fairly lightweight client-side applications so that we can rewrite them when we need to, because we've had to do it several times recently. And we may have to do it again. I mean, I'm not going to tell anybody that other people from Microsoft, I don't work for Microsoft, okay? So people from Microsoft will say, oh, just use whatever they're going to tell you to use, either JavaScript or XAML on WinRT, and then you'll be fine and everything will be rosy. I don't think you should believe that, because among other things, I think this is WinRT, like it's a 1.0 of that. It's going to change. We're going to have a lot of future features. The ones that we have right now will stay. We'll have backwards compatibility, but are you writing the best code that you can in 3 years, or are you going to have to rewrite your code to be the best code it can be in 3 years? Sometimes we have to rewrite, and sometimes we can use legacy code for a very long time. Nothing's going to break. You know, so what you write today is not going to break. It's just, are you going to be where you want to be in 3 years? And the answer is nobody knows, which is unfortunate. It's not the one we want to say. I have one more question, I think.
Question 3A?
3A.
There's still question 3.
Okay.
Okay, my question then is, architecturally, that means thin views make an awful lot of sense in partitioning, but that's not the way developers have traditionally done it. And we keep saying that's a good thing, and everybody keeps hiding ways. And for expediency, we start with the interface, we build it all in user interface. Do you think that that's going to be more important to be successful?
I think that thin clients, so the question is basically, are thin clients going to be important to be successful? And maybe to be successful is thin UI layers. Maybe we're a little bit too strong to say to be successful. So I think that might be a little bit too strong, because Microsoft is pretty good at backwards compatibility. If you write something and it works, it's still going to work. I mean, nobody's going to make your code break, and I want to be really clear on that. It's just we're all trying to see what our skills are going to be and what our applications are going to be in 3 years, and we're trying to get over this. We don't want this much change on the platform this fast. It's just coming too fast. So let's be really clear that I'm not talking about your code breaking. I'm just talking about where we're going to be and what we're going to think is best in a couple of years. And I do think we're going to continue to be pushed towards a thin UI. I think that that's a necessity when our UI is unpredictable. And at the very least, I think we can count on a tablet looking different in 3 years. I don't think this crazy 1,300 pixel wide idea that is the WinPhone standard to have 2 things up is craziness. And I just don't think that's going to stick. So I think we're going to see a lot of changes in what WinRT means as the tablet. So as a Windows tablet evolves into being a Windows tablet. They did too much, let's try to be like the Android and like iOS. And that was silly. They should have gone all the way at the beginning of being a Windows tablet, which means things like, you know, Word's going to run, and you're going to be able to have multiple things open at once, and things you can't do readily on other platforms. You're going to have things side by side you just can't do in the Apple or the Android. So that's just kind of half an answer. But I'm going to talk a little bit more about that once we get to a little bit of WinRT. I'm only going to talk about a little architectural stuff there. So I'm going to get started. That's me. This is just a quick agenda for tonight, and I want to show you the parts I'm going to be focusing on, because this is more material than I'll be able to cover. So I'm going to try to finish in an hour and a half. It's a little longer than you're used to, and I know you're all waiting for a drawing for a laptop, but you know, let's stick with me anyway, because there's lots of stuff to cover. We'll definitely not be doing much with the last 2 items. I might spend 5 minutes on Rosalind if you guys want me to, and we have time. The things that are most important, oops, I thought I had it. Some more things get colored, and they didn't, so let me just find, I'm going to get some help in a minute on this silly, okay, there we go. Okay, so the things that are most important that I most want to do is the overview and trajectory. There's stuff in that's really important for you to see. Async, we're going to spend a lot of time on async, maybe half the talk on async. And then the breaking change, I'm going to make sure you've seen the breaking change for a couple of reasons I'll talk about when I get there. Those are the 3 things I'm going to be focusing on most. We'll flash past a lot of the other stuff. Trajectory. First of all, if you're confused, this is why. We have right now 1.7, 2, 3, 4, 5, 6. What are we missing? We're missing 6 and 7. Haven't found a 6 or 7 yet. If you find one, let me know. These are all upcoming releases. This is not like going back in time. This is all stuff that's like either the best you could do today or what's upcoming. We have all those different numbers, so there's a whole lot of reason to be confused. You might have seen a slide like this. It's just kind of a history where we've been, what's the major things that we've had in each release going forward. This is interesting. Right now we're at 11 and 5, so that's VB11, C#5, and WinRT, which is Win8 support, which I won't be spending a lot of time on, but I will talk architecturally about async and a couple of other things this release. The bigger story right now that I want to make sure people get is that there's a parallel track. And the parallel track is called NuGet. How many of you know what NuGet is? Raise your hand high, because I really want to help Microsoft understand this. So that's about half the room. So thank you very much for that, because that's what I see. I see 25 to 50% of people out there even know what NuGet is. So it's what's called a package manager. And what that means, it's a new way for Microsoft to give you toys. Okay? That's a good thing. And what's even better, there's two things that make NuGet even better. One of which is, if you want it to, it will automatically update. So you can control getting updates in a much better manner than you can with Visual Studio. So Visual Studio is this enormous thing that they put out about every 2.5 years historically. A couple of leaks have happened that says that they may be going faster in the future. But you know, right now, 2.5 years is our history. Enormous big dump on you every 2.5 years. So NuGet allows you to take small pieces as you want to, and you can update them when you want to. So for example, Indy Framework. If you're doing Indy Framework and you want the latest and greatest Indy Framework because you heard about something it does, you can download that and you can say, give me those little spot updates as they happen. Okay, so you can control what you're getting. The other thing is, NuGet can be and often is project specific instead of your computer specific. So you can just think of the fact you might be working in a team. Some members of that team might be on 2 different projects. One project is those teams is on Indy Framework 4.2 and one's on Indy Framework 4.4. It's fine. You can install them. I'm not sure exactly how Indy Framework goes, but you can put them differently on different projects depending on what the tool is that's coming down. So it doesn't necessarily affect your entire machine anymore, which all Visual Studio updates are going to do. So that is going to make your life easier in terms of managing things on your project. This is already in place. This is how we got several versions of Indy Framework out, because we had them come in really fast. And then we also had MVC also came out that way. There's a whole lot of things out there. Also, for those of you that do have organizations that have to put effort into making all your machines for your developers look the same, you can run your own NuGet server. And NuGet also has, there's a whole great richness. If somebody here is doing NuGet or does in the future, it's a great user group talk, because you can definitely spend 1.5 hours or 3 hours talking just about NuGet. I'm just going to say this much about it. Because what I want you to hear from this is that the way you get updates in the future is going to be more sophisticated than what you've gotten in the past, assuming that you want that. Now, you don't have to pull this stuff down, but you're probably going to want to. So there's going to be things like updates to the libraries that are used as part of single-page applications if you're doing that. That will definitely come through NuGet. So the next thing I want to talk about is what side-by-side deployment means and the compatibility implications of this and what that compatibility is. This piece is what I want you to get on the overview and trajectory. This is very important stuff. So the first 3 versions of .NET kind of sat side by side. They just hung out. There was no big deal. They just sat. They were new libraries, brand new libraries. 3.0 was things that sat on top of 2.0. 3.5 was things that sat on top of 2.0 as well. So we built this little stack of stuff that went on 2.0. It doesn't mean the 2.0 libraries were completely unchanged. It meant that there was nothing changed in their design, very few changes, almost 0 changes in anything intentional, and basically they did some bug fixes. But it does not mean it was exactly the same library. And we had a few headaches with that. So they're trying really hard to avoid those headaches, because 4.0 is a brand new set of libraries. That's why those would run side by side on your machine. 4.5 sits on top again. So what this means is that there will be very small changes to the 4.0 libraries as 4.5 is installed on a machine. Let me say that again, on a machine. Okay? What that means is that you could develop and you could target with Visual Studio 2010, you're targeting .NET 4.0. But that could go out on a machine as somebody upgrades for a different reason to have the new .NET 4.0 libraries, which should be identical, should cause you no problems, and the word should is a scary word in that sentence. Okay? So the reason I want you to understand this is so you know where the compatibility problems might come in, and you know how to mitigate them, and you know how this one, I'm going to talk about 2 kinds of compatibility. One's compiler compatibility that you can control, and one is library compatibility that in our 2.0 history, when this happened before, we had trouble controlling when this happened. We had trouble not having machines that were running a different library than we had ever tested on. I think that the takeaway from this is test everything against the new library, unless you absolutely can't do it. Okay, so if you've got code you're responsible for and you can get out there and you can test against the new libraries, you should try to go do that fairly soon. Because if you have a compatibility problem, they'll fix it. At the very least, we need to talk about it if we find some. They are working very, very hard. They got that they hurt people last time. They got that it was a problem 5 years ago. And so they're really trying. They've put an enormous amount of money into this, and they may have done a really good job. I just wish I could tell you for sure, absolutely, don't worry. And I can't say that. So you have to understand that right now we're talking about the library, what the library is you're running against. And so you can run against the new libraries. Now, there's 3 types of compatibility, and there's no one in this room, I believe, that would have thought of all 3 of these if I'd asked you to think of what kind of compatibility problems you might have. So the first one is that what I just described. So you compile one way. You can compile in Visual Studio 2010 against a .NET 4.0 library. Old machine never's had the new libraries on it. That's what you compile in, and you have out there somebody upgrades a machine. You're running on that machine. You're running on the new libraries. The other way it can happen is that you can be in Visual Studio 2012. You can have your machine upgraded, and you actually could, at this point, now be in Visual Studio 2010 as well because your machine is upgraded. You're testing against the new DLLs, the brand new stuff, and then you go out and run on a machine that still has the old ones on it. Okay, so there's 2 ways you can have the cross on the binaries, okay? Now, you may be able to handle that second one because you may be able to force an upgrade. So you may be able to tell people you have to upgrade. You may be able to do that in your deployment pattern. So you may be able to do that. So the first one is you got something out there and it bites you in the field. That's the one Microsoft is working the hardest at. And if you believe you've got one, you've got to tell Microsoft. They're really working at this, and if something gets through, they're going to publicize it. They know that they have to be really good at this. So I actually think they are going to be very good, but I don't want to tell you. And I hate to start this talk with, like, here's the depressing stuff. But I kind of need to. So we start out with understanding how these libraries fit together. The second one is easy, and it doesn't bother me at all. You just need to know it might be out there. So that means that they've changed the namespace, if they've changed something, and you don't compile. Well, guess what? It never leaves your machine. You might waste half a day figuring out what's going on, but that's our worst case scenario, is that you're trying to figure out what's happening. Now, the only place I know of for sure that's going to happen is if you downloaded the async CTP because you wanted to get started on the async stuff I'm talking about. There's a class in there called TaskEX. That class has gone away. And that's because it was intended to kind of patch some things up. And now Task within the threading library already has those features. That's the kind of change that's happened to the 4.0 libraries. So the Task, which is something that was there before, needed to have some extra features for async to work. And they pasted them on and they rolled it in, and that's what's in the new libraries. It's the kind of changes that we need to have there, and that's why they made changes. Whether they should have done this stacky thing again or given us another side-by-side, that's not something there's no sense in even having the conversation because the decision's been made and we can't change it. Okay? You guys with me on that? The last one, I just want to make sure you know about if you're doing serialization. If you're doing anything normal, you don't have to worry about this. If you're doing weird serialization, I do some testing. Because what can happen is you can have 2 things that are serializing fine because you're going old 4.0 to old 4.0. It does fine when you go new 4.0 libraries within the new installation. Oh, new one to new one. Everything's cool. What if you go new one to old one to new one? Okay? And you wouldn't have thought of that. So I just want to make sure this was up there. So if you're doing weird serialization, that you do a little bit of testing to make sure that your serialization is also happy. It should be. This one should be the easy one to test. You know, they shouldn't have been able to break that.
What do you mean by weird serialization?
Oh, if you're doing like some binary stuff and you're counting on something that's like, if you're doing images, something like that, you know, something weird like that. So, I mean, images should be fine. Everything should be fine. But sometimes people go in, they write their own serializers, and they might be doing something strange in there, in which case it's your code. It should be OK. But I would just be a little careful around serialization. Okay? And these are the ones that Microsoft's looking at. This is not a surprise to them. This is actually a modification of a slide that they do. So they do know that they have to check all these things. Non-Intel. So future ARM should all be new, and I wouldn't really expect a problem. But you know, you might be doing something. If they're doing any changes at all, if you're going out to a different platform, they might pick up the change. But I wouldn't really expect to see a problem there. Not any more than anything else. I mean, I would just be keeping an eye on your serialization when you're doing testing. Okay, now that was very depressing, isn't it? So now let me tell you something good about compatibility. They did something really good, so now we can talk about that. Do you remember in previous versions of Visual Studio, if you had a project, so let's say you had a 2005 project and you opened it in 2008, you could never open it again in 2005. And you might read about this on the internet and they'd say, well, the only difference is they changed a number. And the reason they did that was because they couldn't guarantee that somebody out in one of those myriad of files that can be attached to Visual Studio, like the XAML files for workflow or a resx file, or any place in there, somebody made a change that wasn't backwards compatible. And because they couldn't guarantee that nobody made a backwards compatible change, they just didn't let you go backwards. And we've been fighting this battle for 5 years, and I will say they finally listened to the community. It was a lot of work, and we started the battle to make it change now almost 3 years ago. And a lot of people really fought that battle, and we won. So now we have compatibility where you, and I've done it, all these projects. You can open it in Visual Studio 11, which is the one you're going to try. I'm going to try to call 2012, but it's wrong. I get corrected by Microsoft people. The next version, you can open it there and then go open it in Visual Studio 2010. And what that means to you as a developer or you as a team manager is that you can bring your machines forward and your people forward, not your projects forward. So previously, you had people that had to have Visual Studio 2005, 2008, and 2010 all on their machine, and they had to remember every time they opened a project which blasted one that project was in. And if they messed it up, they messed it up, and somebody had to go pull it out of source control and fix it. Okay, it was just dumb. So we're beyond that. That is behind us. And it should be forever behind us because that actually, it was a political decision because they had to say you can't make changes to your structures of your files. And it's a vice president level now. So somebody has to go really high to make a change that doesn't have backwards compatibility, and I just don't think it'll ever happen. And people would be more scared of the vice presidents than actually writing the code to manage to go across 2 different versions of their files. That'll be much easier to do than to talk to a vice president. So I don't think we're going to see that be a problem. So that's a really cool thing. That's a really nice thing about the whole compatibility story. Any questions on any of that? Oh, lots of boring stuff, but it's really important. Mm-hmm.
I do have a question.
Okay.
Does that mean that we're never going to see a solution file that is an MS build file if the file types have to stay the same?
Say that again?
The solution file, .sln,
Uh-huh.
being an actual MS build file, just like a project file is, instead of its own.
Well, it's a broader question. So the question is, will we ever see a solution file that looks like a build file, like a project file does, instead of its own weird little format, which it is right now? And it's a broader question, which is how are they going to actually move things forward now that they can't just go and willy-nilly do this? And I'm going to give a guess as an answer. This isn't a real answer. Is that they're probably going to have like a version of Visual Studio that can open both of them. So you can take, let's just say we did that between 2012 and 2014. Let's just say that we had those releases and we did it. That 2014 would open a 2012 file, use it as a 2012 file, spit it back out as a 2012 file. If you created a new one or you told it to move it into a 2014 format, then it would deal with that. That's the way that should be done, but it hasn't really happened yet. So we don't really know, because we're just starting. Version 1's always easy. Yeah. For compatibility, version 1's always easy. There's no compatibility. So it's just the next one we'll have to worry about that. Okay? Any other questions on that? Okay. I'm just going to go through a couple things on Visual Studio. You'll see it, but just read the slide as I go past it, really quick. I'm not really going to talk about this very much. There's a couple of pretty big changes. I think unit testing should be on there someplace, unless, let's see it. Lots of good stuff going on unit testing. Unit testing kind of got redesigned. The Ultimate people kind of got in and did a bunch of work on that. Some other things are up there. How many of you use, yeah, this is more stuff in there. There's no macros. How many of you have used a macro in the last 2 or 3 years in Visual Studio? Which one? Did you write it? Or you hate them?
Oh yeah, I wrote one to turn on and off the breakout exception.
Okay, so he had something that turned on and off, break on exception. There are existing macros to turn on and off line numbers and to change your font in all of your code windows all at once. So those were existing, those macros are on your machine in 2010. But don't get addicted to them because they're gone in 2012. So what we have to do is we have to find new ways to do that work. So VisX is very complicated, but that's the only answer today, and it will probably be the only answer in the next time frame. We just have to figure out what to do next and what the third party is going to do. But they really are gone. And my slide tells you they're really, 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 truly gone. Okay. How many of you use the Power Tools, the Productivity Power Pack? 5, 6, 7, 8 people? For you, I have to say that it's possible that you will look at the Visual Studio 11 release and say it's not as good a development experience as 2010 was with the Productivity Power Pack. There are improvements that are better, so you make gains over the Productivity Power Pack. You also have some losses. So these are some things that stuck around. Solution Explorer is even better. Some of the other things up here are even better than they were before. Go any place all at once, the little find everything window inside Visual Studio now has an intelligent hotkey. There's some little things like that that are really cool that actually make a difference to your productivity. These are all gone. They're not there right now in Visual Studio 11, and there's some very serious questions as to whether it's a good idea to do a new Productivity Power Pack. They have not announced whether they will do one. And the core reason is that all of the language services will change when Roslyn, which is the next version of Visual Studio, come out. So any work they did on a Productivity Power Tools for Visual Studio 11 would be dead in work. So I can't say that they're going to do it. Okay? Mm-hmm.
I was looking at both slides. I couldn't see tab pinning. Is it gone or?
Tab pinning is there. I have Tabwell on the first one. Tabwell is even better. I'll try to remember to show you the cool new thing that Tabwell does that you will love that is not there in Productivity Power Tools. And it almost makes up for losing this other stuff, but not quite.
And one other thing, too. Solution Navigator is really just dog slow in productivity.
So it's one of the ways Solution Explorer is better. It's one of the ways it's better. I'm not going to say it's blazingly fast, but it is definitely better. So I think it's pretty usable now. Yeah. For the 6 people that did that, this is a really big deal. But for the rest of you, we'll go on. OK, so for WinRT, I'm just going to do some architectural discussion. I'm going to go really fast through this. And I understand that this is actually a core pain point with everybody, and that we could talk about this for hours. And we could talk about some in the bar afterwards. But I'm going to go really fast through this so that we can spend time on async. So first of all, we have something new called a portable library. And a portable library is a library that can run on different platforms. And one of the core problems, so we basically get IL that's going to then go out and be on different platforms. And in theory, this has been there since the beginning. But one of the core issues is that you are going to use techniques that don't work on these other platforms. So one of the things that comes along with this is when you create your project, if you say it's a portable library, it asks you what you're targeting. So you can say, oh, I'm doing XNA and Silverlight. I'm doing Silverlight and .NET 4. I'm doing .NET 4 and WinRT. Whatever you're doing, you just click the boxes. And then it will give you the least common denominator. And that is all IntelliSense is going to give you and help you do. So it's going to be compiling to that least common denominator between all the things that you select. And I haven't gone through to see what's actually left if you pick all of them. So, because there's some differences between them all. So because we have portable libraries, we have some new options. And one of the things that I'm going to talk about here is talking between a client and a server. And I know that's not the only kind of application, but this is kind of the point I want to make, partially because I want you to have some ammunition to talk to your boss. If your boss says that you want, not that kind of server. If your boss says just write it once and run it everywhere, somebody tell me that would work, it's not going to work. And this is going to give you a little bit better visualization of why. Not that server either. Let's try that one. OK, so the first thing, just to get your mind a little bit set, is if we've got a thin client, quote unquote, something out there, then we're doing one of two things, pretty much. We're either taking data from the server, taking it to the client, and building a UI on the client. That would be all of Silverlight. And then that would be JavaScript if you're using a lot of Ajax. So that's if you're doing like a single page application or a lot of Ajax. Then you're doing this one. The other one is you build your UI on your server and you hand it across, and that's HTML. So if you're just building HTML and then you're barfing it across, then that's the second one. There's various spaces in between, but I want us to just kind of get this in our head so that when I go forward and I start talking about where code is, you got a little bit of a grounding of what's happening. So I'm going to talk about a couple of scenarios, and I will tell you, and I'm hoping it will all go smoothly, I added this last line minutes before the talk. I was having a conversation with Mark. I'm sorry. I was having a conversation with Mark, and I thought, gosh, I really should add this last line. So this last line is totally just got added. So let me tell you what I'm trying to express in this slide is that you have some C# code that you can share across all your clients, but it doesn't make any sense on your server. You have some more C# code that you can set, not all your clients, but the last 3 clients. You have some C# code that you can run on those clients and make sense on your server. So that might be a model and maybe a little bit of validation and that kind of stuff. So you can share some stuff. You also have XAML on all of those. I don't think they're going to look the same. So the XAML is between WinRT and Mango is going to use different controls. It's actually going to, the XAML is going to look different. And gosh, the XAML is going to look different in WPF too. And if you're using WinForms, then it's totally different. So, you know, this desktop thing down here is kind of just a conglomeration of just a whole lot of stuff that might be going on that I just squished together just to make the slide so it didn't get too crazy. So yeah, we can share some stuff, but we really, the XAML is going to be a challenge to share in the 2 Silverlight. I'm sorry, because yeah, it's all just going to be different. The form factor is different. The controls are different. Silverlight and XAML, it's all going to just not be quite the same. And then this one, if we need a browser, we also have to do a separate output to our browser. So then we got some JavaScript and HTML5 thing going up on the browser. Okay, so that's not going to work. And then we can put JavaScript. You might have heard JavaScript and WinRT. Okay, maybe it's a brilliant idea. And maybe we're going to bring in millions of JavaScript developers who've just been dying to be on .NET, and the only thing that's kept them away is that they love JavaScript. Maybe. I don't know. You know, I'm thinking you're right. It's kind of not going to happen that way. But JavaScript's better, and we all get to benefit from it because we have to be in JavaScript sometimes. And most of us, many of us. And the JavaScript editor got better, and a lot of things got better because Microsoft believes in this. I don't know why. Because if you haven't seen it, some of the JavaScript you're going to write for WinRT is going to go direct against the WinRT operating system. Gosh, that code's not going to run in your browser, is it? So we've got this, some of the code's going to run and some's not. Can that all be library code? I doubt it. Maybe, but I doubt it. So you're going to wind up not being able to run the same app anyway on WinRT in your browser. Okay, so if you can do everything in the browser, you never had a problem to start with. This is only if you've got an active application that needs to be kind of targeting different things. And now, WinRT in the browser are totally different. Now, we have that leak that says that we're probably going to get WinRT on the next phone. And if that happens, those two may be identical. We may manage to do that. Maybe. I don't know, but they might. But then your WPF stuff is still out in a totally different ballpark. So we really don't have a way, even though we've moved forward, we don't have a way to say, it's just one code base. We're not there. I don't know if we'll ever be there. But if we are, it's a good 3, 4, 5 years away. So this whole craziness, it's part of the answer to your question. It's like, help, we don't want to do this. We really want a better answer. Can you please tell me a way this is all going to just start making sense? The answer is not for a few years. Sorry. I'm sorry. I'm just the messenger. Don't shoot me.
Any rumors that Ballmer's going to retire?
So just if you didn't hear it, any rumors about when Ballmer's going to retire? I don't think we can blame Ballmer for this. I really don't think we can. I could blame some other people for this, but I don't know that Ballmer would be really at the top of my list other than letting some other people run amok. But I'm not going to talk about that because that'll get me in lots of trouble, and I don't want to. The good news for us is that
We can turn the camera off.
No, we're not going to turn the camera off, so I could say things I shouldn't say. I will say the good stuff, which is that with Scott Guthrie being well positioned now, one of the great things in our world is that Scott is so committed to transparency that now, you know, it's actually gotten so transparent that honestly, maybe I shouldn't say this, but I have heard MVPs and other people that are used to being very serious insiders go, wait a minute, we don't hear anything ahead of everybody else now, because you don't. I mean, really, it's all completely transparent, and that's, I think Scott Guthrie has a lot to do with that, and a lot to do with the move towards open source, which I do think is a good thing, but that's a conversation for the bar. Okay, question right here.
If you're one of those unlucky individuals or companies that still stuck on WinForms,
Okay.
until this all gets ironed out, would you wait? Would you start trying to learn XAML? I mean, that's the big thing we're having to deal with right now.
Okay, so the question is, if you're an unlucky individual stuck on WinForms, or your organization is stuck on WinForms, what on earth do you do next? And I would say that waiting is not a bad answer, but you need to be learning something these days. I mean, if you're not learning something, you're just falling behind. It'd be hard for me to tell an organization to ditch their WinForms right now unless they had a clear strategy through this. Because I do think that there's some chance that we will get in the next 3 to 5 years to where there's going to be a winner and a loser. I mean, that this may be VHS and Betamax. I don't know. But if it is VHS and Betamax, then we got XAML and JavaScript. And I think it's hard to say who will win. XAML is vastly better, I think. But JavaScript has a huge following, so I don't know what's going to happen.
Windows 7 might be the
Well, that'd be Windows 8. So is Windows 8 the next the Windows 7?
might be
Oh,
the
Windows
second
7 might be the XP. Well, you know, that gets into the, is anybody going to go to Win 8? And I'll just tell you my 2-second thing on that, which is I'm the only person in the world that thinks that Win 8 will fail on the tablet and win on the desktop. And I definitely think it's going to win on the server. So if you have IT people in your organization, you should, I mean, I'm going to accidentally plug a friend of mine, but you should find money to send them to one of Mark Manasseh's classes, because he's got 2 days of shoving server stuff at people that I don't understand. So if you have an IT organization, I'd be trying to get on top of Win 8 server.
Well, my WinForms app that I have several. Will they run Windows 8 so that can do that?
The question is, will WinForms application run under Win 8? And the answer is, on your desktop, absolutely. They will not run on a tablet. They will not run on an ARM tablet, is my understanding. Okay, so they should run on any place we've got the full operating system. I don't think they'll run on ARM. Okay, anything else? Because I'm like done. I've got one more quick slide, but I don't want to do much with this, so I'm just going to go past it really quick. That's Node.js. I'm not going to talk about it. We got too much stuff to go. Async. Okay, I know at least one person's, was it you that said you're already doing async? Okay. And you said you were doing some async because you were doing threading. How many of you guys have done anything with threading or async before? Raise your hands really high so I can see. Wow. That is like more than, that's amazing. Okay, so I'm going to go fast through a couple of things, and we're going to just go through this. First of all, what the heck is async? Okay, if I go and I ask somebody to make me breakfast, and they make it like this, and they don't start cooking the toast until they're done cooking the bacon, I'm not going back to the restaurant. This is the way this is, you know, serial code, the way we're used to writing it. And if they have to spin off a new thread and create a new cook, every time I wind up with a new, you know, needing something new, that's not going to work very well either. I'm going to just skip past this one because it's just so ugly we don't even have to think about it. This is what we want to do. So what we want to do is be task-based, not thread-based. We want to say, here, I want to do a new task. Now, what I want you to think about for the rest of my talk on asynchrony, unless we have questions at the end of it, is I want you to think about calling another server and waiting for it to come back. A database server or any kind of server. But you're making a server call. I don't want you to think about a thread that's running a hard you know, a lot of calculations on your own machine. Okay, so because I'm going to say stuff like there is no second thread. And if you're running something where you started a thread explicitly, of course there's a second thread. But I want you to think about you're waiting for something happening on another machine for the rest of my async talk until the end and we get some questions. Okay, so a couple things on the mechanics. The point of this slide is that this does work across everything. It just has some different names. That's the first point. And the second point is just that it can, the platform that you're on might do it a little bit differently. I'm going to only talk about a Windows message pump. So this is, let's just go past this. Okay, here we go. This is the normal world that you're used to code in. So we have a message pump, the click event happens, code runs, and we come back, and everybody's happy. Okay? That's normal code. That's what you've always written before, and everybody's happy. You know this kind of code. I'm just showing these as a starting point. Now, this is what happens if you have to call out to a server, and it goes out, and it has to wait. Okay? Now we're stuck. The message pump cannot take another message because it's stuck. Okay? That's when we get the toilet bowl of death. Okay? You've seen it. We want to get around this. This is what we want. And so the click event happened. It doesn't actually anything respond to it until we clear out the other event, and it happens immediately. By the way, these slides are my modifications of some slides by Greg Paparin that Lucian Wilczek is using. The reason we're doing this is we're trying to get the community a model that works, and then people can enhance on this model as we go along. But that's why I'm using someone else's slides here, so we all are talking about the same model. And hopefully I get a video going of this pretty soon. Now here's the new world. Okay, so we go out there, and when we get there, we do something that's very unique that we haven't been able to do before, or we haven't been able to do without writing a lot of code. So what we're going to do is we're going to create something called a task. The way to think about a task is that it's a thing, it's an instance of an object, and inside of it, it has a lambda expression. That lambda expression is everything else that follows in the method. So in this case, we have the await. Oh, I didn't update something in my slides. I'm sorry. If anything's after that. My new slides have something after that, but I'm on a different machine, and I didn't get it moved over. So any code that happens after that await is going to be in a lambda expression. Okay? The lambda expression is held on the task gets returned, and because there's two layers, the task gets returned again, and we're back in the message loop. Now, you've worked naturally across all of your Windows experience with things that took events. You had Windows forms and buttons that took events, so it shouldn't be too big a jump, although it's a little bit of new thinking, to say, oh, well, the task, it can fire an event, and it can accept events. So the first task can accept and it can respond to an event that is, we finished with this network call. Okay? That's normal, and it always goes to the message pump, and that's what we're doing right now. So that once we finish this, first of all, we can handle other operations. The message pump is totally happy responding to whatever else it needs to do right now. Then we actually come back from the network. What it's going to do is it's going to fire events back onto the message pump that says that event was finished. Now run the stuff in that Lambda expression. So if there's anything else following in, in this method over here, it's going to run now. Okay? And then when it's finished, it's going to fire an event that tells the other method, oh, your task is also now complete. So we're just saying, here's a message that says, complete your task. Do what you need to do next. And so then I do have something there. The update view is now going to run. It's going to run because it's inside a Lambda expression. It's inside the task. And then completion, that's what that means. So we're going to run that code. And then we're going to run it now after it takes another message through the message pump. And now we're done, and we can go about our business. Okay? Does that make sense? Any questions on that? Okay, so actually, I think where you're going, I'm gonna answer the question I want you to have asked. Okay? So the question you asked was, if somebody starts spamming that button, what happens? How does it go wrong? Okay? The question I want to answer is, what happens if something shuts the message pump down and the message pump is too busy to get the message you're sending in? Okay? And there's other ways than spamming that button that are more likely to make that happen. Okay? And the answer is it doesn't work. Okay? So I tweeted from last night. You can tweet this again because it's my way to say this. Message pump no worky, async no worky. Okay? You've got to keep that healthy. Okay?
So same threading issues. If you have a rendering and you block on the rendering because you're waiting, then you come back, it'll do the same deadlock.
Absolutely. So if you've done other types of, I'm going to summarize your question in a different way. If you've done other types of threading before, you may have run into this where you blocked your thread. Through many different ways you can block your threads. And if you block this message pump, which is keeping your main thread happy, if you block that, async will not work. And one of the reasons that we're really focusing on the message pump, and I'm using Greg's work here, is because Microsoft's experience with the async CTP was that over half of the people that told them async doesn't work had message pumps that were shut down for some reason or another. Either because they were running they came back onto this thread to run on someplace else. Something was demanding a whole lot of CPU and wasn't giving it back, so they had something else blocking, or because something else was happening that was shutting down this message, like they had a console read in the wrong place. Okay? Now, if it freaks you out that I just said console, I'm going to show you console app. In a console app, which actually, if you know this, it's one place you don't have a Windows message pump. Okay? So the reason what it does, the best way to think about it is that spins one more thread. Nothing else spins a thread. But a console application spins one more thread, and on that thread it runs code that looks just like a Windows message pump. It pulls it through the thread pool, it does some funny things, but that's what's happening, is it's creating its own version of the Windows message pump. And because I'm going to show you a console application, I want to say that in case somebody says, but that's the one case that we wouldn't have the Windows message pump. Okay, you with me so far? Any questions? I bet you are dying to see code because it's a really long time for me to make coders not see code. So thank you for your patience, and let's go look at some code on this. And I need Andrew. Where's Andrew? First of all, Andrew Verme is, did I say it right? Is saving saving me here, because this computer, I'm using a computer that belongs to your user group so we can get the recording done, and I got blown by it. Partially because of this weird thing about the function key and the control key on the left side of laptops. There should be a federal law as to which goes which. There really should be. I mean, it's like microwaves. Okay, hello. Can we please get that done? So it's great because I can then dance around and I can maybe even use my pointer. Yeah, that'd be great. Okay, so what we're doing here is a console application. We're just entry point. We're going to create an instance of a method and we're going to call something on it. Really simple stuff. So we can go over to that async method. Yeah, just go there. So this is an entry point, and you'll see that it's got this async keyword. I haven't really used that word a whole lot because I wanted to wait till we saw code, and you could see this. And I'm going to use a couple of words you may not have heard if you've heard anybody else talk about async before. One of which is async. One of the main things you should think about that saying is it says, I have a special method here. It's special in a couple of ways, one of which is it can only return nothing or a task. It can't return anything else. So I'm returning nothing right here. Okay? I probably will not get to far enough along to talk about nuances of returning nothing, but you will see blog posts on that, and those are very good things to read. But you'll be further along when you read those blog posts. It'd be rare that you use void. You'll almost always return a task. Okay? It's just to keep this simple. So what we're going to do here is we're going to await a long-running application, a long-running operation. So if we remember how .NET runs code, we're going to first run the inside, return that value, and pass it to the outside. Okay? So if we go down to long-running operation, which is down here, you'll see that it's another async. It returns a task. It returns a task of int. Okay? And it's just, you can read it. I mean, it's just going to do this little simulation. You can't do a thread.sleep. You know why you can't do a thread.sleep, right?
Async thread.
I just showed you be shutting down that message pump, so it would kill you. Okay? So you have to use delay. Delay is like a timer that doesn't screw up the message pump. That's the way to think about it. So I'm just doing this, a random delay, and then I'm just saying when I'm done. And this is one of the places that this gets a little bit weird, because this method returns a task, but it tells me I'm returning an integer. So that's an integer, 1, 2, 3. Can you just change 1, 2, 3 to 42 just so nobody thinks that's magic? So we're just returning a value, but that's an integer, and you say returning a task. Okay? So most of the time, like 85% of the time, you're going to be able to look at this in a very naive manner and get the right thinking. But that extra 10 or 15 or 20% of the time, I need you to understand. And that's what I'm going to spend a lot of time thinking of. So I'm going to make this a little harder than it will be most of the time you're looking at your code, because I want you to understand it. And then you can think of it in a more naive way. OK, so await is actually return. OK, so at this point right there, at the await, it returns the task. The task contains a lambda expression, which is everything else in the method, which is the console write line and the return statement. So the lambda expression returns an integer. Okay? Does that make a little bit of sense? With me? Okay. So the lambda expression returns the integer, not the await is, it could have been return async. They could have called it return async. They just decided to call it await for some other reasons. But that's what it's doing. So we get the task back there. If we go back up to the run, this extra layer is just in there because I'm going to use it in a minute. So I've got another method. It takes the task, which long-running operation returns, and it simply returns that. We'll be using that in a minute, and that's why I wanted all these to look the same, and we're just going to build on them. Can you guys see okay? I'm trying to kind of stay where the camera's not too bad. OK. And then we return that. So what I want to do is the first thing I want you to do is Control F5, and then we'll put some breakpoints in. We're first just going to run it. Now, it can do one of two things because, actually, that's the next one. This one's not going to time out. It's just going to say it's done. How long it took to do that is going to vary. Can you do it again and make sure that we see it's going to wait? Just press it and run it again. Okay, so we have to wait. We're waiting for that delay. And then it finishes and we get 42 and we're done. Okay? Now, if you can step through the code, if you can put a breakpoint on in program, put a breakpoint on console write line where it says returning. Yeah, we can just walk through that part, but I want a breakpoint there for sure. And then I want a breakpoint in the long-running operation on done. Any place else you guys see you think you want a breakpoint? Is that going to be a good start? OK. So if you can just do a debug. So we immediately got there, didn't we? Really quick. OK? So everything ran, and at this point, we're waiting. We're just hanging out. By the way, there's a read line down further here if you're wondering why the application's not finished. That's another mistake a lot of people made with their sample apps, is forgetting that you still have to pause the thing. OK, so then it's going to, as soon as he hits F5, it's going to bounce to the other breakpoint because we've been more than 2 seconds. Something else to think about as you're trying to debug this stuff is if you've got delays in there, as soon as you hit your breakpoint, you're going to just go there. You guys following how this goes? Do we need to do anything else stepping through it? Anybody have any questions? Because I'm about to make it harder because you're never going to write code like this. OK? I'll tell you the 3 reasons you're not. You're going to go, you're right. Timeouts? Oh, yeah. We're going to have to wait. We're going to have some sort of timeout behavior. That may never come back from that server. Exceptions? Oh, yeah. We got to do something with exceptions, don't we? And cancellation. And those 3 things is what makes the change. So we're going to look at all 3 of them if we have time. I gotta go really fast then, oh my gosh, okay. So can you go to async, the async is of async 0, and it's in this comment out, I think you're there. Let me know if you need help. Okay, I'll talk while he does that. So the way that this sample app, the next one, yeah, that one. Yeah. So the way this sample app is set up is there's just a bunch of code. You can take a look at it. Just uncomment them kind of one at a time, because if you do all of them, it's going to surprise you, except at some point do it. And then see if you predicted the way it was going to run. And walk through it and make sure it all makes sense. Because then you're going to have them all running at once. And you're going to have all this stuff awaiting all at once. And you can play with that, but we're not going to do it together. OK, so if we look at that code, exactly the same code here, no difference at all. If we go to that code, we're going to say timeout. And I think you're going to write code like this. I think you're going to have all your timeouts like having in one place. So what I've done, and it's why I wrote that other code in a kind of funny way, is we still have a long-running operation. But now we have, instead of a method called run, we have one called run or timeout. And we pass in what the timeout length is, which is 3,000 milliseconds. So if we look at the, go down to the long-running operation is the same. So if we go to run or timeout. So now we take a task. Remember that came back from the long-running operation. So it runs to the point that starts to await, hands a task back, hangs out, puts the rest of the stuff into a Lambda expression. Okay? And then at that point, we're here, and we have what's called a when any. You can predict what that does. It says this one finishes or this one finishes. When one finishes, I'm done, throw the other one away. Okay? So either we finish or we time out. You're going to do this all the time.
So you just kind of stack two of them.
You stack two of them, and the first one that comes back is the only one you cared about. Okay? You know that whether or not you timed out because it's not completed. So if you complete, you're complete. If you don't complete, you assume you timed out.
But I'm assuming that other task, if you were timing out, let's say it took 20 seconds, it would still continue working and using resources. Whatever it is.
Good question, and I don't know if I'm going to get to, I will tell you that the third sample I've got that I probably will not get to talks about that problem. It talks about it in relation to a cancellation instead of a timeout, but it does talk about exactly that problem. Okay? Yes?
Okay, built on this though, this is, if it's on the same thread, then there's not a race condition to worry about, because often when you're doing a timeout in the same thing, you're worried about the race coming back.
Right. This is, okay, so the question is, oh, so because it's on the same thread, you don't have to worry about a race condition. And this is absolutely true. This is why it's important they designed it the way they did. Yes, it saves a lot of resources to not have a second thread, but the bigger thing is that you don't have to worry about all that hard stuff. When you go read the threading articles from the last 5 years, you don't have to worry about all that hard stuff. Okay, race conditions being only one of them, but that's the big one. Okay, so you don't have to worry about that stuff because you only have one thread, unless you spin a second thread, but that's not what we're talking about right now. We're talking only about just going off to a server, doing something simple. So we're not wasting resources. That's all you have to do to timeout.
Quick question. Thread costs about a meg for every time you spin a thread. What's the context of a task in terms of context?
Okay.
It used to be the stack and all that other stuff.
So the question is, how expensive is it? It's very expensive to spin a thread. It is not very expensive to do this. There are some articles on that. I'm going to point you to those articles. There's one in my final slide because it's a very complicated, the answer gets very complicated. And it's not really what it's spinning. It's that the IL has so many more lines in it. Because the IL to do this is actually very ugly. And so that's why there is a performance hit. It's fairly small. But you do want to be aware of that in certain cases. Okay? Now, what I think I'm going to do is I'm going to fly through. I'm not even going to run this. I'm just going to show you what a cancellation looks like so you get that. And I'm going to, I should throw an exception. We should probably throw an exception. If you go down to the long-running operation, I made a change to it, and I put a try-catch in there. And so if you comment out the line that below that says throw a divide by zero exception, the point of what I'm going to walk through right now is that exceptions run in the naive way you think about it. Behind the scenes, great ugliness happens, including a state machine. Okay? There's ugliness in the background. But in terms of the way you think about the code, it works the way that you're going to think about this code in a very natural way. So what's going to happen is I'm going to throw a divide by zero exception. It'll be caught. It'll be changed into a new kind of exception, which is an invalid operation exception. And then if you go up to the try-catch in the containing stuff, remember, this isn't a Lambda expression. And remember, only part of that's actually in the Lambda expression. So we're really making, it's really funny if you think about what that Lambda expression would actually look like. But it works. It does the right thing. And then up above where we have the, yeah, right there. You were in the right code. Right there. If we don't time out, then we're going to have this exception is going to come. Now, Let me just make sure that you understand the way this code runs. I got two things I'm doing at the same time. I'm doing a timeout against a random value. So I'm going to get one of these exceptions, but I don't know which one I'm going to get. So I'm either going to time out or I'm going to get an exception. So if you want to run that, and you can just do a Control F5 if we have breakpoints. You probably don't here. OK, what's going to happen? Timeout. OK, run it again. It happened I had to do it 4 times last night. So let's see how many times I have to do it. Timeout. Do it one more time. Oh, oops. No, no. Wait. Do it again. OK. Oh, I know why it said oops. It says oops because, I don't know. Operation's not valid. OK, so it hit the invalid operation exception exactly the way you would expect it to happen. OK. The other thing I want to say is that you do not need that try catch in the long-running operation because if it had thrown the divide by 0, it would have just gotten here anyway. I just only needed to do that because I wanted to change what the exception was to show you that that all just is normal. The thing about exceptions is it's just normal. OK? Behind the scenes, it's not, believe me. But in terms of the way you write your code, as long as you don't have to think about that lambda expression, as soon as you have to start thinking about that lambda expression, then you're going to have to start thinking, oh, it's only got half of it. The try catch is like outside the lambda expression. How does this work? And that gets a little bit crazy. But try not to think about it if you don't need to.
Is the stack still correct?
Yeah, well, to the extent that in terms of the try catch, they actually have to build a new try catch, and then it ties into the old one. It does weird stuff that I don't want to think about. Yeah, the IL really is pretty bad here, OK? If you want to understand what it's actually doing, because that's important to you to get to the bottom of it, that's fine. I'm just not going to go there right now. OK, so now if we look at the next one, so we don't just talk about async. So the next one is it shows you how to cancel, OK? So if you think about cancellation, and I hate the naming here, so I'm going to have to talk more than I'd like to, because I think that if their naming was right, I wouldn't have to explain this. So their naming's wrong, but we have to live with it, OK? So in a cancellation situation, you have 2 players. You have a canceler and a cancel-e, OK? So you have something, you have a button somebody can push. You have something that can happen. It's going to hit a handler, and that's going to say, would you please cancel now? Then you also have something that's going to be canceled, OK? You don't want the thing that's going to be able to be able to cancel itself unless you explicitly want that to happen. In most cases, you do not want that to happen. In most cases, you want one thing to be able to cancel and something else to be canceled. That's the common case. So we have 2 players, and we have what's called a cancellation token source. That is who can cancel. And we have a cancellation token, which is watch that thing, and it'll tell you when it's been canceled. So other code has to watch that and keep looking at it. And as soon as it's canceled, then it will know. So that's what knows the cancellation happened. So cancellation token is held within the cancellation token source. You with me? OK, now the thing about this, if we can look at the code, the async code for this, don't look at this code too much right now, because this is the hard code. It's actually calling the cancellation that's harder in this case. So if we go down, we have the cancellation token got passed in to the async timeout method. We passed it in. We passed it to the long-running operation, which passed it to delay. We're done. That's all you have to do. Because delay is something in the framework that knows how to watch that. If you write some long-running operation, you're running on a separate thread, you got a loop, and it's doing 89 million things, then you have to watch it. But if you're talking to somebody in the framework, they already know how to watch it. That's it. We just canceled. OK? That's all it takes. Incredibly easy to do. I don't know if we'll run this or not, just in the interest of time. But what I do want to show you is how we were going to. We'll run this, because I'll explain how we're going to run it. Let's go back to program. And so what we're doing here, and this takes a little bit more thinking, OK, is we're going to call that. We're going to get a task back. OK? And we're going to read. We're going to wait. We're waiting. We're waiting. We're freezing the machine up. Oh, I mean, not the machine, but we're freezing up what we're doing on the machine. Now, if we hit return really fast, OK, it's going to cancel. It hasn't had a time to finish. But if we don't hit return, it's just going to finish normally, except that it's going to not actually, it's going to tell us it finished, but we're going to have to hit read line, enter to clear by the read line. Kind of with me on that? A little bit? It's a little bit confusing on that, but maybe it'll make more sense if I just have Andrew do exactly what, just run it, and as soon as it comes up, hit enter. The task was canceled, OK? So we were able to cancel. It's that simple to do cancellation. You will have cancel. There's no reason not to allow cancellation. If there's a chance, if your UI can come up long enough that somebody's actually going to be able to push the button, give them the button. It's that easy to do. OK? Exceptions are easy. Cancellation's easy. Timeouts are easy. Cool. This is what we gain by the fact that we have code that hurts our head at one point, because we have to learn the async keyword. What does that mean? It means it's a special method and it will return task or nothing. Okay? We have to learn the await keyword. What does that mean? It means return task. It could have said return async, return task. That would have been maybe a better name. That stuff will take you a little bit to get your head through, a little bit to get around this lambda expression thing. You're going to be grabbing a lambda expression. And nobody stopped me there. I didn't even tell you what a lambda expression was, which is effectively a delegate. It just means a pointer to a function. We're going to take that code. We're going to run it later. And exceptions just magically happen through. They did all the hard work for that. They did this because async is this important. The WinRT rule is 50 milliseconds. It could take longer than 50 milliseconds. You are supposed to do it in an async manner. That is incredibly fast. The world is going to async. We can't stop it. We have to be on board. Microsoft did a lot of work to get you this far. Now, you may have to see this a couple of times because it is a little bit tricky to get your head around. My code is not doing what it's saying exactly the way I thought it would. But we have actually a toehold into some incredibly complex things. One of the things that's very difficult to write yourself if you do this kind of work yourself and you got events coming back and all this kind of stuff, is what if I'm waiting for something and when it comes back I take that value and I send it to the next thing. So let's say I have to call a service and it's going to tell me what URL to call to get some more information, which is going to give me a URL to call something to get more information. So what that's going to look like here is it's going to be await. Everything following that will be in a lambda expression, including the next await. So when that comes back, the lambda expression runs, it has another await. That calls, it goes to the next await, which is in the next lambda expression. Now you can get your head around that pretty easily. The code is extremely easy to read, but you don't want to write that yourself. It's really hard to manage those kinds of things. In addition to WinAny, there's a WinAll, which is kind of, it's the part that answers your question. I'm not going to go into that code right now. It's the other sample that I've got here. So you have a WinAny and a WinAll, and you can put them together any way you want to. So if you just need to spin off 6 processes, and all you care about is that they all come back and give you a value, it's great. You can do that. You can do the first one comes back, stops, and any combination you can do from there. If you want to do in a series, you would do a series of await. Those are the 3 scenarios I can imagine.
When you do have a cancellation, do you have the ability to book like a compensation event for a lambda expression that you
So
can run?
when you say a compensation event, do you mean like a synchronization, or do you mean just a cleanup?
You're doing an async that also supports cancellation. So then when the user decides to cancel, it may be more than just a classic database transaction that just gets rolled back. You may need to do some custom development for your own compensation logic.
And the answer is yes, but you may have to do a more complex WinAll and pick up pieces of a lambda expression after that. So the answer to that is going to be there's going to be a whole series of patterns that we're going to hear about over the next couple of months. And you're going to be able to build on this, and that people are going to go through the scenarios. Right now, the best source is something I've got a link to in my last slide, which is Lucian Wilczyk's 101 samples. And then we're going to get some more samples, which are some real-world ones out there. So I can't go through all of those little scenarios. I don't want to give you a half-baked answer on that, but the answer is yes, you will be able to. I don't want to try to draw it out for you right now. Okay? Mark?
Okay, 2 ways they can be doing this. Are they doing this as delegates, just tossing delegates across with lambda as our concept? Or are they doing expression trees, basically the expression trees that the lambda can represent, and then passing that, and it's being done intelligently? Or
So
we don't know.
So the question is it a lambda expression or is it a delegate? And I got asked that last night, and which is interesting. It's interesting I got asked it because I never thought about it before. And the answer is I believe it is a delegate because I can think of no value of it being an expression, but I do not know if I'm correct. But because I don't know if I'm correct, I'm still saying lambda. But it could be that it is just a delegate, and I should find out, and I haven't yet. And if somebody reminds me, I will blog on it. I just am very bad about remembering what I say in a talk that I will blog on. So if somebody sends me something, I will find out, and I will make sure it's blogged. I will either link to it, or I will write it myself.
A lambda would be very flexible, but it would be slow. And that's why I don't think it would be a lambda, or actually be an expression tree.
As long as we only, so the question is, if we have an expression tree, it's going to be slow. So as long as we only evaluate it once, it's probably going to be okay because we had to bring it in anyway. I really don't know which it is. So I'm not going to try to make too much, I'm not going to make a guess on that. Are there any other questions on async? Because I'm going to leave async and talk about a couple of other things because I don't want to keep you here quite all night. I would like to, but I'm not going to. Because there's a laptop involved, for heaven's sakes. I can't keep you here all night. Yes, I'm going to put it on my blog. The question is, will the code be available? I'll put it on my blog. This is everything we did right now, everything we've done so far. You see the gray outline? This is Visual Studio 11. Okay? If there's no color, it's the Visual Studio 11 beta. They have heard that we don't like it. They assured us they've heard. Now, does that mean exactly what they're going to do? I've got absolutely no idea. So I don't know how much color we're going to get. We will get some color. And hopefully it will not be like,
The title bar.
yeah, or like bad splashes of color just because we said we wanted color. But you know, we're not going to get a solution like we want, like us being able to control icon sets. We're not going to get that. But we will get some color because this really stinks. And what's worse is that because it's black and white, there's only so many icons up there. And Peter Ritchie put together a bar that I saw that had like, it had like 4 or 5 icons, and he said every single one was something different. And there was like repeats. There was be like 4 or 5 of one icon, 4 or 5 of another icon, 4 or 5 of another icon. He said every single one was a different thing. So they're also ambiguous. So this is a mess, and they're gonna fix it somewhat. They don't have a lot of time. I would not expect a fix that we're really going to be happy with, but it'll be better. You didn't notice it was all gray? Yeah, there's no color outside of the code, none at all. That was the design decision that somebody made. Yeah. Anyway, I won't tell you the other things that are wrong with that. But now you've also seen it. And just real quick, can you do something? Oh, it's up there. You see that thing over on the right? Someplace along the line, he went to async 2. He probably did it by doing an F12, just a go-to definition. And he may have also gone someplace else. So that is the thing that's added to the tab well that's so cool, is that it will keep reusing that one spot. So you know when you're debugging and you're going like through the call stack and you keep opening new things and eventually you throw your hands up and you just close everything and start over? And it's because you were going through it. You know that, right? Okay, so the cool thing is that all of those ones you're just doing in passing and it thinks you're not serious about, it keeps putting them in the same place, and there's only one of them, okay? Now if you want to move it across, that little dot over there it's I don't know what it says, it's like open or something like that, but that little dot over there will make it real, okay? Or if you edit it, it'll automatically become real. So it pops over and becomes real. Is that cool? Yeah. That is so cool. As the coolest thing, I think, in Visual Studio, the new version, compared to the Power Pack especially, because they really got that one right. They nailed that one. So yeah. OK, so I'm going to go back to slides unless I have any other questions right now. Whew. Thanks for sticking with me on async. I mean, the third time you see this, it's going to be easy. You know, I keep trying to improve exactly how I teach this, but yeah, it's a lot to throw at you. And if you just kind of keep that in mind, this little task is running around and being completed and running its Lambda expression after it gets completed, then I think that that's a good model. And I think I'll go ahead and take over again here and go through some more slides. Oh, this is just a slide to remind you that thing about that naming that I don't happen to like very much. I think it's really confusing. That's all this is. It's just a slide to remind you of that. And what else do we get to talk about? Caller info. Oh, Andrew, I'm going to need you again. I'm sorry. Sorry. This will just go better. I'm going to have you I'm going to have you advance slides too. So if you go back to the code, there's what you're going to get with the download is going to be a solution that has like 4 or 5 console applications in it, and each one is a console app. So you have to set it startup to run. We're not going to run this one. We're just going to look at it. So if we look at the caller info code, in the caller info right there. Okay, you see something funny you've never seen before, and you scratch your head on this for just a minute. And what we're doing here is this code, for whatever reason, wants to know who called it. There's a couple of reasons. One, it might be a piece of logging code. It's actually doing a logging operation. It also may be something called I notify property changed. How many of you know what I'm talking about when I say I notify property changed? You know that 7 or 8 lines of code you just can't quite seem to get out of every single property? Well, if you had a piece of code that knew who was calling it, it knows the name of the property now. And so now all of a sudden we have new things we can do. So for those are 2 scenarios we know that it's going to wind up used. It's funny syntax because what they did is they said, we're going to use an attribute for this. Okay? It has to be an optional parameter because you're never going to pass this parameter. Or you're never going to get the right one if you pass it, okay? You don't want to pass this one. So when it comes across this attribute on a parameter that nobody gave it data for, so there's no argument passed, instead of being this empty string that you're using in order to make the compiler work, because the compiler would fail, because the method calling this isn't passing anything. So instead of that empty string, you're going to get the actual who called you. Kind of funny, but it works. So for the 3 times you need this, which aren't very many, it's there, and then it's really cool. Okay?
You you would use reflection to do that before this came out.
So
does this use reflection in the background?
So the question is, you would use reflection before, or you would use the call stack, both of which are very expensive operations. And the answer is no, they don't. It's actually uses compiler magic behind the scenes and uses the attribute. And I actually don't know exactly what it's doing. I haven't looked at the IL, but it does not have the performance hit that you would have, particularly the call stack, which is an extremely expensive hit to make. You just can't. You just really can't do it. Okay.
So an aspect indicative of more aspect-oriented programming. Is C# driven more in that direction? Because I like what I'm seeing at being able to actually apply attributes at the parameter level. Or is this just a trick you do just to do this one thing and that's it?
So the question is, does this mean that we're moving towards aspect-oriented programming? And the answer is that in Visual Studio 11, no. This is a one-off trick that they did with the compiler. You can't do this at home. Don't try to do it. The next version of Visual Studio, if I get a chance to talk about it, is going to have, or the one after that, hopefully the next one, will have something called Roslyn in it. And Roslyn is going to allow us to do aspect-oriented programming. So not in 11, but the one after or the one after that, hopefully the next one, we will be doing aspect-oriented programming, I hope. Now there is some chance that that will come out with the underpinnings of what we need for aspect-oriented programming, but shut down because of a release cycle requirements. They may not have time to open up the things that they're doing to allow us to do that in the future. They're rewriting the compilers, and the new compilers will allow us to do that. And I just don't know if I'm going to get a chance to talk about that. I'm going to look at my time in just a second. So if you want to go back to slides here, that's it. That's all there is to that one. We'll advance to the next slide. OK, this one I really need to show you, and this is going to hurt your heads really bad. OK? So what I want to do is I want you to look at this code for just a minute. I'm not going to give you a whole lot of time on it. I want somebody to tell me what they think this is going to do. Nobody wants to make a guess? Anybody want to make a guess? What did you say?
9.
Andrew says it's going to print 999999999. Anybody think it's going to do anything else? Anybody believe Andrew? Do you want to go to the go to .NET 4.0 and run the code that should just run when you run that up? So this is exactly the same code, no difference whatsoever. Okay, let's run it. Let's see what happens. And you can use, this, I don't know if magnifier's on there. If you can't see it, it says 999. I just don't know if we have a magnifier here ready to go. OK, why did it do that? Everybody's going, huh? Last night I was in Lansing, and nobody got it. OK, I shouldn't say that, because somebody's going to say, Lansing, nobody saw it. Andrew did. Can we go back to the code here for a minute? I'll show you why. That's because this is what's called a closure. So what happens is this happens since .NET 2.0. And anonymous methods. OK, so what happens is that we actually take the variable I, the actual variable I, goes along for the ride in that lambda expression, right there. The actual variable goes. OK, that's what a closure means. That's the way lambdas work. That's the way anonymous method works. That's critical to a boatload of stuff that we take for granted. But it also means that code doesn't do what you thought it was going to do. OK? Doesn't do it. You guys didn't all go, yeah, I know what that code does. Microsoft decided, A, that was true, that most people didn't understand what it was going to do. And B, are you going to fix it for me? Why don't you fix it for me? And B, with async, it will happen way more often. Now, you're not going to write code that looks like this. You're going to write code that's got a collection of customers or something else, and you're going to be going through it, and you may have had link involved, and a bunch of other stuff may have been going on. And at the end of the day, you wind up with code that doesn't do what you want. He just fixed it. Okay? What he did was created a new variable. We still carry the variable along for the ride, but now every time we come through the loop, we create a new variable and take the new variable along for the ride, and it has the value of the variable. You with that change? OK, that's exactly. And I'm not even going to bother running the code. Trust me, it says 1, 2, 3, 4, 5, 6, 7, 8, 9.
You did.
Oh, you just ran it? Oh, I was going to show you. Visual Studio 11. Visual Studio 11, you don't put that code in; it just happens. OK? So he could run it if he wants to, but that will work. But over in here, if he makes that run, and you look at exactly the code we saw before, and it says 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. But if we look at that code, you don't see that X. It's done behind the scenes for you. OK? There it is. That's the code we first had. It happened magically for you. OK? You're pretty much happy this happened.
This must be the break
It's the breaking change. Okay, here's the thing about this breaking change. And I'm all over this because nobody else is. This is why I'm like screaming about this. Because what you need to know is that Microsoft says, you know what, nobody did that on purpose. Okay, you're probably right. And they say, I don't think almost anybody has that in their code. I don't think almost anybody ever did that. I don't think it's out there very much. Okay, you may be right. That's the wrong question. The right question is, how do you guys guarantee it's not in your code? That's the question. And there's an answer. There's a couple of answers. It's just when they come out, you need to pay attention. You need to actually do this. It'll be out in the blog sphere before we release. It'll be fine. There's going to be a tool you're going to run across your code, and it's going to tell you. And I'm very confident this is going to happen. It doesn't exist yet. I may write it in Roslyn. Someone else may write an FX cop rule. Somebody may write a stock cop rule. There may be a competition among who's going to have the coolest tool, because everybody's going to go download this tool, and somebody's going to get 8 million downloads on some tool someplace, and that'd be kind of cool. And also, ReSharper does it right now. So if you're using ReSharper, it does it. I understand DevExpress might do it, and I don't know about Telerik. So we got 3 people out there. And so the other way it might happen is we may get one of these companies or more than one of them to split that out of their tools or give you a free way that you can get their tool, run it. And the worst case is, oh, I hate to say this because it's so mean. The worst case is everyone who doesn't have ReSharper will go out to JetBrains, they'll download the 30-day trial, they'll run it against their code, and they'll find out whether they've got this bug. And I think that that's not nice to JetBrains. But if it works, it works. So you will be able to do it. There will be blog posts about it. I just want you to have seen it. And I want to remind you about closures. Because I give this talk, I talk about this, and the vast majority of people go, I don't want to say it, but I thought it was going to do that 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 thing the first time. You really surprised me that it didn't. Now, what's the 10? The 10 is if we go down, that one's not fixed. Okay? I can tell you the reason is that they think that that looks like the code actually is a closure. And they think that what you're going to do with the other one is not. Mine look the same because I made them look the same. Okay? But if the first one is across a list of customers or something, it's going to be much harder to see. So this one is not going to change. It prints 10 because we go through the loop 9 times. The variable is the last value, which is 10, and then it prints that 10 times. You know, this conversation has gone on a lot. Microsoft talked about this a lot. This was like a really hard thing for them to get to the other side of. And I can tell you that the reason is that they believe that in most code, not code like mine that's written explicitly to show this problem, that the first one is going to be nearly impossible to see, and that this one, when you look at that code, you're going to see it. I don't know if they're right or not, but that is the reason that I understand it was done this way. And VB, by the way, is identical. Everything I said right now about C# is exactly the same on VB.
VB.NET has a compiler warning.
Except for that. Thank you. Yes, except the VB doesn't. VB already knows. The VB people may have been ignoring the warning, but then they can just go unignore the warning. So VB had a warning on this built in from the beginning. Okay? So I tell you, if it's my tool, it's going to tell you about this one too and tell you to get rid of this one too. But it's not fixed. And the reason I don't care all that much on this one is because you shouldn't write, this code doesn't make sense. You know? So if you need this, you can lift it yourself. So as long as you got a tool to tell you it's out there, and hopefully at some point C# have the warning, but I do not believe C# will have the warning in Dev 11. It doesn't right now. Okay? Whew, that was hard. Okay. So now we're going to go back to slides. And I'm going to let you stay up here and take me through slides. Next one. He's been awesome. OK, we did those. OK, couple things in Visual Basic. How many Visual Basic coders do I have? A couple of them. So the only thing that, you know, some of this is pretty obvious. Global means that you can ignore your project level namespace. It's a really big deal. We really like that. If you got burned by that ever, you're really happy now. OK, next one. BCL stuff really quick. How many of you understand the garbage collection as it actually runs right now? You understand what Gen 0, Gen 1, Gen 2 is? Then read the slide. OK, this is one. It's like everybody else just forget what the slide says. You don't care. So it's better. Garbage collection is better. And if you understand Gen 0 and Gen 1, you go, oh, cool, they do that. That's cool, good, good, good. The one thing most people don't know is that there is such a thing as server garbage collection. I don't know very much about it because this isn't really something I care a whole lot about. But if you think maybe you want to find out more about server garbage collection, go look it up. It has a significant change that's a big deal. That's it. We can go on. Okay, this one's craziness. This has got to get fixed, but I'm going to tell you what it is right now, and it's just got to get fixed. Okay, so any CPU. If I say, how many of you know right now, you could tell me what your application, what platform you target with the applications you have deployed right now? How many of you can tell me that? Okay, for sure. Less than 10% of the people in the room. Okay? Have you gotten burned? You have to set it. And you got burned in 2008, didn't you? Yep. Okay, so let me tell you the story. It's kind of up here, but I'm going to kind of tell you the story. So what happened is we started having 64-bit applications. I mean machines, 64-bit machines. And they said, oh, you're going to want to run 64-bit applications on 64-bit machines. So we're going to put this switch, the default in 2008, is going to be any CPU. And what that means is we build the IL, we go to the machine we're deploying on, and we make 64-bit IL. 64-bit machine code if we're on a 64-bit machine, and 32-bit machine code if we're on a 32-bit machine. Doesn't that sound like a good idea? It sounds like a great idea, except that 64-bit DLLs can't call 32-bit DLLs. So, people have gotten burned by this, go, oh yeah, I know. And Crystal Reports happened to be one of those 32-bit DLLs, but there was others. I don't know which one you got burned by. So all of a sudden what this meant back in 2008 days was that your application didn't run on somebody's machine. And it ran fine on your machine, and you had some people it broke on. It broke on his machine, but not his machine, and his machine, but not his machine. And then somebody said, well, these are the new machines. And you finally got to the bottom of it and realized that that was a stupid switch for you to be using because you don't need the features of a 64-bit application. And gosh, let's just run it and compile it as a 32-bit application. So along comes 2010, and for new applications, not the one you brought forward, but new applications, the default now is x86, which is 32-bit application. Cool, we fixed the problem, right? Yes. Except now we're going to make it a big mess again, because the default now is any CPU prefer 32-bit. Do you have any idea what that does from the name? Will you be a little surprised that what it means is compile to x86 unless you happen to be an ARM processor, and then go ahead and compile for an ARM processor? Is that what you thought that was going to be? No. It isn't, is it? And just in case, in the unlikely event, you still aren't confused, we aren't going to put it in the box over there as any CPU prefer 32-bit. We're going to put it in that box as any CPU, which remember is the one you're scared of because it bit you back in the days of Visual Studio 2008. Okay? So this is so bad they've got to fix it. But that's what it is right now. And then there's this little thing that says prefer 32-bit, which I guess means but it doesn't work right now, and it's just total craziness right now. So just be aware that you really should think a little bit about what you're targeting. You probably want to target x86. This new switch, any CPU prefer 32-bit, that's the new default, and it's a good default. But it's just we changed the default on every one of the last 3 releases. Okay, so you needed to hear that. Yeah, I'm telling you all the I don't work for Microsoft, if you noticed that. Okay. What's next? We're almost done. MEF. I'm going to skip this, and I'm just going to let people read the slides. So if you're an IOC person, you're afraid of MEF, MEF fixed its biggest problems. That's a summary of the slide, but I'm way out of time. I'm way out of time. Okay. Next is, we're not going to do this. Just kind of go through these at about 3 seconds apiece, or that's fine. That's fine. You guys can look at the slides. I'll put them on my blog. I'll get a PDF of them you can take a look at. This is just a few things that I think is interesting that's happening. The minification in web is probably the biggest one, so you can do that automatically. So Rosalind, I have a question. We're probably going to stop right now. I just want to ask you first. I can do 5 minutes on Rosalind if you want to know what's coming after this. What do you guys want? Let me see a show of hands. Do you want to see Rosalind? Yeah. Okay. Gosh, you want to see Rosalind instead of drawing for a laptop. I am touched.
We want them both.
Well, you're still going to draw for the laptop, okay? It's still going to be there, but let's just do this first. Okay. So I'm going to go ahead and Andrew just click when I tell him to click, and that'll be fine. Then I can wave my hands. Thank you so much. He's really helping me out. Okay. So all we're doing on the surface, I think this is like a watershed moment. I think it's enormous. I mean, like the biggest thing that's happened since we started writing English language. I mean, really big, okay? But the reason isn't Rosalind itself. It's that we had this enormous avalanche ready to happen. And this is going to be the snowball that gets tossed in to cause this big avalanche. And I'm writing about this on my blog some. I'll have some more blog posts on it. So I'm not going to go into that in a lot of detail, but I'm going to tell you what's going to happen. and try to give you a feeling for why it's going to be enormous over the next 5 years. This is going to kind of be slow in coming. We're going to redo the compiler. Traditionally, what a compiler does, it says, I'm going to build a syntax tree, which takes the code, puts it in something it can work with. And then it does what's called binding. And that you can think about that as it hooks all the symbols up. That's one way to think about it. And you get a semantic tree. Semantic tree is the logical tree for your application, basically. And then the next thing a compiler does, guaranteed up until today, is it throws it away. That's what it does. I mean, it just doesn't care because we didn't used to care. The big thing that Roslyn does is it says, oh, we're going to keep it. We're going to let you have it. We're going to make that data that's available. And that's what Roslyn does. And that sounds like such a tiny, tiny, tiny thing. But the reason I think it's huge is I think it's going to start a process that we already have started, actually. But why I say we've already started, we can talk about it, Bar, you can read my blog, to redefine what it means to be a program. If I ask you today what a computer program is, you're going to open code and show me code. That's what you're going to do. Almost everybody's going to do that. A small minority will do a couple of other things. But that's what you're going to do, OK? This will change. You will no longer think about your code as that text. And that's been blocking us from moving forward. That's why it's big. But I'm also now going to show you what it actually is. So we're going to do this little graphic thing. Oh, this is stuff we're going to get for free. We're just going to ignore this right now. You're going to get some cool toys along the way. But I'm not going to talk about that right now. You get scripting. Anybody want scripting? You get scripting now. OK, go on. OK, so this is what compiler looks like right now. Code goes to IL. And I don't know how, you're just going to hit, and I don't know how many we actually are going to hit here. So hit a couple more times, at least once more. Oh, so you can do pre and post compilation. You can do that today. Some of you are doing that right now. That's today's compiler. What we're going to do, go ahead, next. Then we're going to take that step out. We're going to go to a syntax tree, a semantic tree. We're going to keep them around. And we're going to go to code. And that's the change. OK? And you go, that was really small. But remember, the reason is that now we're going to start thinking in broader terms, in terms we don't know what it's going to look like right now. We don't know where we're going. OK? So then we can put special code all these different places. That's a little bit interesting. We can take the semantic tree in particular and spin off. Hit that again. And we can take that information. We can create the darndest IDE tools you've ever seen. IntelliSense is going to look wimpy. We're going to do amazing things we can't even think of. That's part of what's going to have us start thinking as normal coders more broadly about our code, because these things are going to happen all the time. Refactoring is going to be the major way we write code. It's really going to be a big shift on that. So we can do that. Hit it again. And that's going to give us a semantic tree. And another thing we can do is, guess what? That syntax tree doesn't have to come from text. How's that? So if you hit it again, it can come from someplace else. OK? It can come from maybe a whole different place, a different set of text. Maybe it's still text, but it's a different place. It's an execution window. It's the immediate window. But you can write methods in the immediate window, and they're going to stick around, and you can then call them. OK? That's there today. That's called REPL. It's in the sample today on Roslyn. OK? It's called REPL. You can do that today. Or it could be code generation. Or it could be something else. You can embed information in your code and rewrite. That's what gets us to aspect. This is how we can do aspects. Is because we're going to be able to rewrite just like that. We won't think twice about it. Where a rewriter today is a big investment, it's something you get scared of putting in your code, you're a little careful about it. Okay, for some good reasons. It's not something you're just going to blink and, oh, sure, I'll put a rewriter in. Because the rewriter is going to be inside the compiler, and we're going to have standard patterns to do it. So our code isn't our code anymore. Our code is what we say, and then we have, like, we back up by one whole step. We got machine code, we've got IL, we've got code. Now we're going to be able to work one step back further, naturally, without us having to do DSLs and hard stuff. Now we can just have, if you hit it again, we're going to see some stuff. Oh, that's just how we can control that. We'll do all these things for sure. This stuff is already there today. But the cool thing is I don't know what we're going to have. So we're going to have first generation we understand, second generation we can predict, around the third generation we get fuzzy, and it's the 10th generation where I think we'll be probably in 5 years. That's why the fact we will think about our code differently opens up an entire new world for us. And that's why I'm so excited about Roslyn and so excited about what leaders in the community and people in the community pushing. At the very least, what's going to happen is that this stuff we're doing right now, where the unit test people, the agile people, they're like solving the problem with a spoon. They're writing all these little unit tests. At the very least, we will have unit tests written for us. Good ones. Much better than packs. Much better than what we've done before. And this is the change I think is coming that's so exciting. And I'm going to stop there. Thank you very much for your patience and letting me run over. Thanks so much. And we'll get to a laptop drawing here in just a minute. Thank you.